Hello everyone, my name is Rahul. So today we are going to see about mechanical plating and cladding. At the end of this video, you will come to know what is meant by mechanical plating and cladding, what are the components of mechanical plating and the types of cladding. So mechanical plating. Mechanical plating, it imparts the coating by cold welding fine metal particles to a workpiece. Joining takes place without fusion or heating at the interface of the two parts to be welded. Unlike fusion welding, where no liquid or molten phase is present in the joint, typically it's used for hardened steel parts for automobiles with plating thickness less than 25 micrometer. Next, mechanical plating, other names. Some of the other names are mechanical coating, pin plating, impact coating. As you can see in this picture, glass beads are sprayed along with the metal powder to the surface of the material that is needed to be plated. Process of mechanical plating. First, descaling and cleaning is done to remove any soil or other particles deposited on the workpiece. They are generally carried out in the tumbler or in the separate cleaning system. After cleaning, the parts are prepared with water, medium, and the surface conditioners. The accelerants and the promoters provide proper chemical environment for the plating to occur, and also to maintain pH at 1 to 2 to prevent oxidation and promote adhesion, which is very important. Next, coating materials that are used for mechanical plating include zinc, cadmium, tin, copper, and aluminum. Among these five, zinc is the mostly used coating material. Next, components of mechanical plating. First, plating barrels or tumbler. It's the most important part of the mechanical plating machine. It has a tulip design, as you can see, and it's made of steel or stainless steel. It has acid resistance coated layer on the inside to prevent any corrosion that occurs while pouring of acids or some other components. So the working volume of the barrel is generally about 25 to 30% of the total volume for most plating process. The tumbler is usually run at a speed of 60 rpm, but it can also vary according to the needs of the plating. So if it runs fast, then the lumpy deposits will form on the workpiece. If the speed is too slow, then the metal powder will not be deposited on the workpiece. So these are some of its drawbacks. There next is the surge hopper. The plated particles come into the surge hopper and then to the separator, allowing the operator to perform the next sets of operations. Separator. Next component is the separator. Separator separates the coated workpiece from the medium after coating. It can be as simple as screen with water nozzles or as complicated as vibrating system with magnetic separators. Next is the chromator. Chromator is optional one because if you needed for any corrosion protection, you can use a chromate by spraying with the chromate. Dryer. The next component is the dryer. Workpiece are taken to the dryer to remove any moisture that is present on them. Usually centrifugal dryers are used. However, oven can also be used for larger parts of loads. Next, it's the typical mechanical plating installation. As you can see, the components, various components of it. Next is the mechanical zinc plating, which is one of mechanical plating. Mechanical zinc plating is accomplished by tumbling small parts in a drum with zinc and chemicals. Small iron and steel parts are cleaned and flash copper coated before loading into the plating barrel. The barrel is then loaded with chemicals, glass beads, and zinc powder. During tumbling process, the glass beads peen zinc powder on the part of the material that is being coated, that is being plated. Then the parts are taken out, dried, and then packaged. Usually they are used for parts not suited for hard dip galvanizing. Next, coating characteristics. Mechanical plating consists of first flash coated with copper and then followed by zinc coating. The coating upon micro cross section appears to consist of flattened particles of zinc loosely bonded together, because in mechanical plating the zinc deposition will be lesser in amount, while in hot dip galvanization the zinc deposition will be 30% more than the mechanical plating of same volume. Next, it's a video on mechanical zinc plating process. First you can see that tumbler rotating. Now they will add the workpiece into the tumbler, where other chemical components and the coating materials are
This process
present
eliminates
inside.
the risk of breakage of high tensile strength disc springs and washers due to hydrogen embrittlement. It is ROHS compliant, which is an environment friendly process. Coating thickness up to 50 microns can be achieved.
Next, the advantages of mechanical plating. One of its primary advantage is that no hydrogen embrittlement is formed in this process. Hydrogen embrittlement is the main reason for cracks and other things that leads to the weakening of the component. In mechanical plating, uniform coating can be achieved, whereas in electrolyte plating it cannot be achieved. Porous substance can also be coated in mechanical plating. Not only flat surfaces, porous surfaces can also be coated easily. It's ideal for sintered components, which normally require surface preparation to stop ingress of aqueous solutions into pores. It's a cost effective process also, and it's also environmental friendly. Next, applications of mechanical plating. Some of its applications are its nuts, screws, nail washers, stampings, clips, and hardened parts of steel for automobiles. Next topic is the cladding. Cladding is the bonding together of dissimilar metals. Cladding is often achieved by extruding two metals through a die, as well as pressing or rolling sheets together under pressure. Examples of cladding is the cladding of 2024 aluminum clad with 1230 aluminum, and 3003, 6061 and 7178 aluminum clad with 7072 aluminum. Other applications are steel clad with stainless steels or nickel alloys. Cladding is of generally of three types, of course. First one is the roll bonding. Two or more layers of different metals are cleaned and then passed through a pair of rollers under sufficient pressure to bond the layers. And then the explosive welding. In explosive welding, the pressure to bond the two layers is provided by the detonation of a sheet of chemical explosion. Third one is the laser cladding. Laser cladding is the method of deposition of a material by which a powder or wire feedstock material is melted and consolidated by use of a laser in order to coat part of the substrate. It is often used to improve mechanical properties or increase the corrosion resistance. In the diagram you can see a powder like substance which is metallic in nature and is injected into the system by a nozzle. Interaction of metallic powder and the laser causes melting to occur, which is then deposited on the substrate. It has an advantage that if any defect is there in the substrate, it can also rectify that. So thank you.